41 days ago, a deep-sea research submarine operating roughly 340 miles southeast of the Azores picked up a faint, repetitive ping coming from the seafloor at a depth of just under 3,900 meters. The crew logged the signal, assumed they had stumbled onto debris from an old maritime accident, and continued their survey. When they returned the following week with recovery equipment, what they pulled from the sediment was not a piece of hull, not a ship's transponder, not a fishing beacon. It was a flight data recorder, a black box of a type used in large commercial aircraft. And according to every aviation authority on both sides of the Atlantic, no plane has ever gone down in that area. That, at least, is the short version. The longer version, which is where this story gets interesting, involves a set of oceanographic records that do not quite match each other, a pinger frequency that does not quite match civilian aviation standards, and a handful of researchers who are now arguing quietly about whether the object recovered is a black box, a military device that resembles one, or a modified piece of equipment that has no official public record of existing at all. Let's step back before we step forward. A flight data recorder, often called a black box even though they are traditionally painted bright orange, is a piece of equipment installed in essentially every commercial aircraft in the world. It captures two kinds of information. The flight data recorder itself logs hundreds of parameters about the aircraft, things like altitude, airspeed, engine performance, control surface positions, fuel flow. The cockpit voice recorder, often paired with it, captures audio from inside the flight deck. Both devices are built to survive. Modern units are expected to endure impact forces of 3,400 degrees, fire at over 1,100 degrees Celsius for an hour, and pressure equivalent to 20,000 feet of seawater. They contain underwater locator beacons, called pingers, which activate on contact with water and transmit a signal at 37.5 kilohertz for roughly 30 days. That is the international civilian standard. The object recovered near the Azores has been reported, in leaked briefing notes, to be pinging at a frequency slightly off that standard. That detail on its own has generated much of the speculation now circulating online. Here is what is publicly confirmed. A Portuguese-flagged research submarine, contracted by a joint European oceanographic team, recovered an object consistent in size and shape with a flight data recorder from the Atlantic seabed in early March. The object was transferred to a facility on the mainland, photographed by at least one person with access to it, and described in a preliminary write-up circulated among marine researchers. It is approximately 40 centimeters long. It is scourged. It carries impact damage consistent with having struck a hard surface at speed. It has no visible manufacturer's serial number, although a portion of its casing has been ground or corroded in a way that suggests identifying marks may have been removed or simply lost to the environment. Here is what is not publicly confirmed: whether the device is civilian or military, whether it came from an aircraft at all, whether the data inside can be recovered, and, most provocatively, which flight it might have belonged to. That last part is where the story gets uncomfortable, because aviation authorities, when asked about aircraft losses in that specific stretch of ocean, have come back with essentially the same answer. There are no unresolved commercial aviation incidents in that exact region within the design battery life of a standard pinger. The nearest historical losses are hundreds of miles away, decades old, and in most cases already accounted for through earlier recoveries. If this is a civilian flight recorder, it is one whose parent aircraft has never been officially reported missing, which has produced a range of competing explanations, each of which has to be taken seriously. The simplest is also, in a way, the least satisfying. The device could have drifted. Ocean currents in the North Atlantic, particularly the subtropical gyre, can move debris enormous distances over time. A flight data recorder lost decades ago in a known incident could, in principle, have been carried by bottom currents into the area where it was eventually found. The problem with that reading is that black boxes are dense. They do not float. Once they sink, they tend to stay put, with only limited lateral movement from seabed currents. For a unit to have traveled hundreds of miles, something unusual would have had to happen, and the scorched, impacted state of the casing suggests the device hit the water close to where it ended up. A second explanation is that the device is not civilian at all. Several national militaries operate aircraft and drones that carry flight data recording equipment similar in external appearance to civilian black boxes, but tuned for different purposes and different frequencies. An unacknowledged military loss is, by design, something the public is not supposed to know about. Crashes of test aircraft, reconnaissance drones, or classified platforms are routinely either undisclosed or described with language vague enough to prevent identification. If a military aircraft went down over the mid-Atlantic, most of the public would have no reliable way to learn about it through official channels. Under this reading, the object recovered is real, its pinger frequency is real, and its absence from civil aviation records is perfectly consistent with it never having belonged to a civilian flight. A third explanation, which tends to get the most attention online, goes further. It proposes that the device comes from an aircraft, possibly crewed, that was never meant to be part of any publicly documented flight at all. This is the claim that has generated headlines. It leans on a long-running argument that certain flights, either test programs, covert transports, or aircraft of uncertain origin, operate outside the usual radar and regulatory footprint. Under this reading, the black box is genuine, but its aircraft is, to borrow a phrase, off the books. That third explanation is also the one that deserves the most scrutiny, because it is the most dramatic and the least supported by hard evidence. The gap between an unexplained device on the seabed and a covert flight network is enormous. You can walk that gap only by making a lot of assumptions. And in the history of mysterious recoveries, the assumption that lands closest to a conspiracy almost always turns out to be wrong, while the boring explanations, such as mislabeled equipment, drift, or undisclosed but ordinary military incidents, turn out to be right. Still, a few specific details in this case make it harder to simply shrug off. The pinger frequency, if the leaked numbers are accurate, is close to but not identical to the standard 37.5 kHz. Some aviation-related military beacons do operate at slightly different frequencies, which is an argument for the military origin reading. But the reported number does not cleanly match any known published standard, civilian or otherwise, which leaves at least some room to ask what kind of device was actually being pulled up. The casing material, according to the same leaked notes, contains a titanium alloy mix that is unusual for standard civilian recorders. Commercial black boxes are typically built from hardened stainless steel with ceramic and high-density insulation inside. A heavy titanium casing is not unheard of, particularly in experimental or high-performance contexts, but it is not the default. If this detail holds up under formal analysis, it pushes the origin of the device toward the non-civilian end of the spectrum. The pattern of damage to the outside of the unit is also, by some accounts, inconsistent with a simple high-altitude aircraft impact. A flight data recorder that falls with a crashing airliner typically shows a specific combination of thermal damage, compression from the fuselage collapsing around it, and saltwater corrosion acquired over time on the seabed. The object recovered near the Azores is reported to show thermal damage that looks more like sustained exposure to very high heat, possibly from something other than a fuel fire, along with impact patterns more consistent with striking water at a steep angle and at speed. Those details are still preliminary, still unpublished in any peer-reviewed form, and could easily be revised as more careful analysis is done. But they are part of why the conversation among marine engineers has not been quiet. Skepticism has its own seat at this table, and the case for a more boring answer remains strong. Ocean recoveries are messy. Many objects on the seabed have unusual shapes, unusual materials, and unusual damage because the ocean is, bluntly, an unusual environment. A device that looks like a black box may be a research buoy. A sonar array component, a decommissioned naval asset, or a piece of equipment from a research vessel that sank decades ago. Human memory is short. Ocean records are incomplete. And the further back you go, the easier it is for a lost piece of equipment to disappear from the paperwork, even if it never really disappeared from the world. A short tour through past recoveries makes this point harder to dismiss. In 1968, a U.S. Navy submarine called the Scorpion was lost near the Azores, not far from the region in question. Parts of its wreckage were located and documented, but other pieces have drifted or been rediscovered in later decades, sometimes by accident, during unrelated surveys. In 1998, an airline flight from New York crashed off the coast of Nova Scotia, and small fragments from that incident continued to wash up for years along the Atlantic coast, some of them carrying manufacturer markings that took time to match. In 2009, the loss of a transatlantic flight over the mid-Atlantic produced a recovery operation that lasted 2 years and required remote submersibles working at depths comparable to the one near the Azores. Each of these incidents left behind debris fields that are, even now, not fully mapped. Any single recovered object in the North Atlantic has to be checked against these histories before any more exotic explanation is entertained. It also helps to understand how difficult deep-sea recovery actually is. At nearly 4,000 meters, pressures exceed 380 atmospheres. Temperatures sit just above freezing. Visibility is effectively zero without artificial light. A submarine operating at that depth is, in practical terms, working blind, relying on sonar, pre-mapped coordinates, and robotic arms guided by surface operators with a transmission delay. The fact that a device was recovered at all is, in itself, a minor technical achievement. The fact that it was spotted by chance during a routine survey is more remarkable than most reporting has acknowledged. Had the submarine passed a few hundred meters to either side, the object would likely still be on the seafloor, silent, for another generation. This raises a sober question about what else is down there. The North Atlantic has been a corridor for air and sea traffic for well over a century. Shipwrecks from both world wars, lost fishing vessels, fallen satellites, jettisoned fuel tanks, research equipment, and, yes, crashed aircraft all contribute to a quiet layer of human history spread across the seabed. Most of it has never been cataloged. Most of it never will be, at least not within the next several decades. Any given square kilometer of deep Atlantic may hold artifacts no currently active agency is looking for. The recovered object near the Azores is one data point. It implies a much larger set of data points we have not yet encountered. Dr. Henrik Larsen, a Danish oceanographer specializing in seafloor recoveries, has publicly urged journalists to slow down. In a short interview, he pointed out that every decade or so, the deep Atlantic produces a find that at first looks impossible, and, after careful analysis, turns out to be the boring remnant of something we had simply forgotten to record. He said, in so many words, that the most interesting part of the ocean floor is often not the object, but the archive we failed to keep. That is a useful reminder. It does not, however, settle the case. What happens next with the recovered device will depend on institutional will. The Portuguese research team has handed the object over to a joint European aviation safety body, which is reportedly working with engineers from multiple agencies to open the casing, inspect the internal memory, and attempt any data recovery that remains possible. Black box memory is designed to survive. Even fire-damaged and pressure-crushed recorders have, in past investigations, yielded usable data after careful forensic work. If the device turns out to carry flight data, and if that data matches any known aircraft registration, the story closes quickly and quietly. If the memory is wiped, the data is encrypted beyond normal civilian standards, or the serials simply do not match any aircraft in any registry, the story opens up in ways that are harder to predict. Either way, the broader pattern the event points to is worth considering on its own. We tell ourselves, comfortably, that we know what is in our skies. We track flights through global networks, coordinate airspace across dozens of agencies, and publish remarkably detailed statistics every year about how many aircraft take off and land and how many are lost. That comfort is partly real and partly imagined. The oceans in particular remain the deepest blind spot in our civilization's attention. Most of the seabed has never been mapped in any detail. Acoustic monitoring is sparse in vast regions. Debris can sink for decades before being noticed, and even then, only if someone with the right equipment happens to be in the right spot at the right time. In other words, the possibility that a device could end up on the Atlantic floor, pinging quietly, waiting to be found, without any public record of how it got there, is not an exotic scenario. It is a natural consequence of how wide the oceans are and how limited our attention is. We should probably expect more of these finds, not fewer, as deep-sea research expands. Whether the object near the Azores turns out to be civilian, military, experimental, or something we don't yet have a category for, the most honest takeaway is modest. Our maps of what has happened in our airspace are not as complete as we sometimes pretend. Our ocean is full of objects we did not place there, and the line between what we publicly know and what is quietly buried on the seabed is thinner than most people realize. The data recorder, whatever it ultimately proves to have been, is now being opened in a controlled environment. In the coming weeks and months, there will be updates. Some will be definitive. Most, in practice, will not. And even if the case resolves neatly, the underlying question it raised will not go away, because the ocean will keep producing objects like this, and our attention will keep being narrower than the world we live on. If you have a theory about what the device is, where it came from, or how it ended up where it did, this is the kind of story that invites that kind of thinking. Just remember, while you theorize, that the likeliest answer is often the one that looks least exciting on a thumbnail. And also remember that most likely is not the same as certain, and that every so often, the Mid-Atlantic genuinely does surprise everyone. The maritime community has seen something close to this before, and those precedents are worth pulling forward. In the early 2000s, a research vessel working in the Pacific recovered what was initially described as a Cold War-era communications buoy. After months of analysis and quiet cross-checking with archival records, the object turned out to be a decades-old piece of commercial oceanographic equipment whose parent project had been dissolved without clear asset transfer. The paperwork existed, but it had been scattered across 3 different organizations, none of which had a strong incentive to claim the device. Similar stories have played out with sonar buoys in the North Sea, research floats in the Indian Ocean, and navigation aids in the Arctic. In each case, the original mystery was resolved, but slowly and with far less public attention than the initial recovery received. That pattern is probably the most honest precedent to keep in mind when thinking about the Azores find. It is also worth noting that the reporting on this story has been unusually fragmented. Some details have come from the research team itself, in carefully worded briefings. Other details have come from leaked internal notes, whose accuracy has not been independently verified. A handful of claims circulating online appear to trace back to a single anonymous source, with others reshaping the story in each retelling. This is not a case where the full picture has been released to the public in a clean, authoritative way. Any summary, including this one, is working from partial information, and any confident reading in either direction, mundane or exotic, deserves to be held loosely for now. There is one more angle worth naming, because it often gets lost in the noise around stories like this. Most unexplained objects, in every field of investigation, turn out to have explanations that are mundane, specific, and eventually convincing. The story just doesn't travel well. A black box that turns out to belong to a long-decommissioned research platform rarely makes a headline after the exciting part dies down. That asymmetry in how stories are told leaves the public with a distorted impression. We remember the recovery. We rarely hear the follow-up that drains the mystery out. In practical terms, the most likely ending for the Azores device is an unglamorous one. Someone, somewhere, will eventually identify what it is, file a short report, and move on. The parts of this story that suggest something stranger are real, but they are also the parts most likely to shrink under proper examination. Still, a margin of genuine uncertainty always remains. Not every deep-sea recovery ends with a clean identification. Some objects stay ambiguous, either because their origin records were lost, because the agencies responsible declined to claim them, or because the damage on recovery made identification impossible. In those cases, the object simply joins a quiet catalog of unresolved finds, neither extraordinary nor dismissed, waiting for a future investigator who has better tools or access to records that are still classified today. It is entirely possible that the Azores device will end up in that category. It would not be the first, and it will not be the last. The ping has now stopped. The pinger battery is long dead. Whatever the device knows, it knows in silence, waiting for someone with the right tools and the right patience to listen.